Okay? Remember, you can always pick whatever seems the easiest to do. Okay? So if you can factor one of these easier than the other, I would do that. If I'm looking at these, I see that my denominator has prime numbers for both my leading coefficient and my constant. So that's the one I would probably start with. Okay? And so if I looked at that, I could either do this by trial and error or by rewriting the middle term. Okay? Because these are prime numbers, trial and error is going to be pretty quick. So 3p and p, I know my last is a positive, meaning the signs have to be the same. So they're either both positives or negatives. Since the sum is negative, I know they have to be negatives here. And so I only have to test two combinations, 1 and 5 or 5 and 1. So if I do my outer and inners here, I get a negative 15 minus 1 gives me my negative 16. And so that means that first one I tested is going to be correct. So here are my factors. What that allows me to do, once I find one set of factors, is it allows me to plan for the fact that one of these factors will likely cancel. Again, it's not a guarantee, but more than likely, since we're working on simplifying and canceling factors, one of these will be a factor of this numerator. So which one is the one more likely to be a factor of that? 3p minus 1, right? Because there is no factor 5 at the end. So if I set up my first factor of 3p minus 1, it just allows me to do trial and error very quickly. My second binomial factor starts with a p, also a negative, and then the other factor, when I FOIL this, it gives me a last of positive 4, would need to be a negative 4. And then if I test my outer and inner, I see that I get negative 13, so that confirms. Those are my factors. Once I have them, I can cancel any common factors, and I get my answer, p minus 4 divided by p minus 5. Okay, on these ones, when you have multiple terms as factors in your numerator and or denominator, you do need to have grouping symbols around them. So you do need parentheses for each of these. And then because you canceled this factor completely, you do have to exclude that domain restriction as long as it's not apparent in the simplified form. Okay, and so you can see here the shortcut for finding a 0 that corresponds to a factor is take the opposite of the constant and divide by the leading coefficient. So the opposite of negative 1 is positive 1, divide by 3. So here's my excluded value. Is that apparent from my simplified form that x can't be 1/3? No. So I have to leave it as this additional exclusion, and that would be my solution here.